Hi guys, welcome you all to my channel Explore Edu to Teach.
So the next concept in electronics devices and circuit will be about capacitance. We'll be talking about different kind of capacitance like the transit capacitance, the diffusion capacitance, the depletion region of the PN junction, the electric field equations, and finally we'll be solving one gate problem in it. So please listen to this concept very well, make a note of this. All these concepts and the necessary formulae will be put up on my Instagram page. The Instagram page link is given down in the description box. Please go and check it from there. It's a very important kind of topic and there are many formulas in this topic, so you might get confused. All those formulas in a concise manner will be given onto my Instagram page, so you can definitely go check the links in the description box. Go and check out my Instagram page, and if you like it you can follow me on Instagram as well. Also do not forget to like, share, subscribe to my YouTube channel and follow me on Instagram as well. So let's begin with capacitance. So there are two kinds of capacitance. One is the transit capacitance, other one is the diffusion capacitance. So the transit capacitance, most importantly, is when the PN junction is reversed biased. So when the PN junction is reversed biased, it is called, the capacitance is the transit capacitance. The depletion region acts as an insulator or a dielectric medium. Thus the PN junction acts like a parallel plate capacitor. That is very important. So what do you mean by transit capacitance? Transit capacitance means the same thing, that when your PN junction is reverse biased, the depletion region acts like an insulator or a dielectric medium, and that PN junction is called as the parallel plate capacitor. So always remember, a transit capacitance is formed when the PN junction is reverse biased. The transit capacitance is given by the formula dq by dV, where dq stands for increase in the charge or change in the charge, and dV is called as change in the voltage. Transit capacitance can also be given as epsilon into A by W, where epsilon is equal to epsilon naught into epsilon R. Epsilon naught is 8.85 into 10 raised to minus 12 farads per meter, and epsilon R is the relative permittivity. A is the area of the cross section and W is the width of the depletion region. So this is very important. There are two kinds of capacitance. One is the transit capacitance, other one is the diffusion capacitance. The transit capacitance comes under the picture when my PN junction is reverse biased. The transit capacitance is given as dq by dV. dq is the change in the charge, dV is the change in the voltage. The transit capacitance given as epsilon into A by W. Epsilon is equal to epsilon naught into epsilon R. A is the area of the cross section and W is the width of the depletion region. Similarly, you have the diffusion capacitance. The diffusion capacitance, unlike the transit capacitance which is a reversed bias, in case of diffusion capacitance, the PN junction is forward biased and the capacitance is called as the diffusion capacitance. The formula is given as tau into I upon neta Vt, where tau is the mean lifetime of the charge carrier, I is the diode current, neta is the ideality factor basically, or the generation recombination factor. This neta is 1 for germanium, 2 for silicon, and Vt is the applied forward voltage. So what you need to actually know is that there are two kinds of capacitance. One is the transit capacitance, other one is the diffusion capacitance. In case of a transit capacitance, the PN junction is reverse biased, whereas in case of diffusion capacitance, the PN junction is forward biased, and the capacitance evolving out of it is called as the diffusion capacitance. The formulas you need to know it very well, because there are numericals in which the terms will be given to you and you will be asked to find out the relative transit capacitance or diffusion capacitance. So knowing the terms very well is very important. I will be these notes are present in the description box of my YouTube video. Also the formula sheet in a concise manner is present on my Instagram page. Please check out the links given down in the description box of my Instagram page as well. Next is the depletion region of the PN junction. Now the depletion region of the PN junction is given as 2 into epsilon into Vb upon Q into 1 by Na plus 1 by Nd the whole raised to n. So the n stands for half or 1 by 3. Half is basically abrupt or step graded PN junction, and 1 by 3 is linearly graded PN junction. I repeat myself, the depletion region width of a PN junction is given as 2 into epsilon into Vb upon Q into 1 by Na plus 1 by Nd the whole raised to n, where n is equal to half for a step graded PN junction and n is equal to 1 by 3 for a linearly graded PN junction. Please remember these formulas. It's a very formula oriented video, but I am still teaching you so that when you apply these formulas onto the numerical, you will know each and every term meaning. That is very important. The epsilon, as I told you, is epsilon naught into epsilon r. The Vb is basically the built-in is basically, you can say, the barrier potential, wherein the V0 is the built-in potential, the Vf is the forward voltage, and the Vr is the reverse voltage. So depending upon forward voltage or reverse voltage, you can find out the Vb value. The Na and Nd is given as acceptor concentration and donor concentration. So if you see the formula of your Vb is V0 plus Vr or Vf minus V0. Now Vr or Vf is directly given to you, but V0, which is the built-in voltage, is given by this formula, which is given as Kt by Q into ln of Na into Nd by Ni square. I repeat again, these formulas I am reading and telling you, not just to tell you, but to make you understand every term that goes into the formula. When you look at the formula over here, it is a very simple formula, which is given as 2 epsilon Vb upon Q into 1 by Na plus 1 by Nd, the whole raised to n. But then you should know what is epsilon equal to. Epsilon is epsilon naught into epsilon r. What is my Vb equal to? Vb can be V0 plus Vr or Vf minus V0, where my V0 is given by this particular formula. Then there is Q, then there is Na, then there is Nd. So knowing this formula well is very, very, very important. Next thing, we have the electric field equations. The electric field equation is given as Q into Na into Wp upon epsilon into Q into Nd into Wn upon epsilon. I hope I am very clear. The maximum electric field is given as by this formula, Q into Na into Wp upon epsilon, Q into Nd into Wn upon epsilon. Again, the point comes, the Q is the charge, Na, as I told you, is the acceptor concentration, Nd is the donor concentration, epsilon is epsilon naught into epsilon r, then what remains is Wp or Wn. The Wp is given by this formula, W into Nd upon Na plus Nd, and Wn is given as W into Na upon Na plus Nd. So you should know this formula very well. I understand there are many formulas to remember, but this kind of questions come on this formula only. And trust me guys, if you know the formula, which looks very difficult initially to remember, but if you keep on revising this formula, keep on writing down this formula, you will remember it well. And if you understand its basic terms inside it, you're able to pick the correct term from the question, place it into your formula, do no errors. Trust me guys, you will get marks in it. Even as we will be solving the numerical from gate examination also, from university exam also, you will be seeing that the questions are simply formula driven. They will give you terms in a split manner, wherein you will have to take each and every term, map it onto this formula, and you can get the final answer. Provided you remember the formula well, know each and every term very well, and you are not doing any calculation mistake. So let's try to understand the one numerical that we will be understanding today. Then in the future classes we will be solving more numericals, as you can see over here. But today we will be solving one of the most basic numerical. So this is a gate asked question. This depends just on the basic formula, the basic understanding which you have learnt in the earlier classes. If you haven't watched those videos, please go and watch it down. It is there in the EDC channel playlist of mine. The question says a silicon bar is doped with donor impurities. So there is a silicon bar which is doped with donor impurities Nd. So what do you understand by this? Since it is doped with Nd, donor impurities, it is a N kind of semiconductor. They are given you the value of Ni, which is the intrinsic concentration, as 1.5 into 10 raised to 10 per centimeter cube at temperature 300 Kelvin. Assuming complete ionization, equilibrium electron and hole concentration are what? So if I talk about this thing, as I told you, the silicon bar is with donor impurities. All the reasons, everything is marked up in my notes. You can get the notes from the description box link, and you can learn it and practice it on your own. So as the particular silicon bar is doped with donor atoms, the semiconductor is called as a N type of semiconductor. In this N kind of semiconductor, the electron concentration is given as Nd, which is 2.25 into 10 raised to 15 atoms per centimeter cube. Therefore, the final formula is Ni square is equal to Np, P is equal to Ni square by N, and my P, this is the formula. Hence, from this formula, I get my hole concentration, which is P, and I get my electron concentration, which is N. So I hope I am very clear with this. So this is a basic formula wherein they told that the silicon bar is doped with donor atoms, hence it is Nd. Once you know N, you can also get P from this basic formula. All the formulas are already uploaded on my Instagram page. The new formula will be keeping on uploading on my Instagram page. So please check out my Instagram page, and if you like it, do follow me on Instagram as well. The links are given down in the description box. So thank you so much guys. God bless, and like, share, subscribe to my YouTube channel as well. Thank you.